Welcome to Coffee, Contractors, and Concrete, a podcast series focusing on all aspects of the surface preparation industry and brought to you by the industry experts at Buy Manufacturers Direct. Joining the podcast today is Substrate Technology President, Industry Patriarch, social media educator, and leading subject matter expert, Josh Jones. All right, Josh, now I want to talk about another mechanical process that's very popular, shot blasting. There's a lot of questions about shot blasting. Years ago, it was very popular, but because of the popularity of grinding, it seems to kind of have taken its back seat, but it's still a very viable process. Tell us a little bit, what is shot blasting from that 30,000 foot perspective? Why is it still necessary in surface preparation when we have all these grinders out there?
The best way to explain shot blasting to, let's say, someone who hasn't seen it or run it is it's like a sandblaster, except dustless, or like a pressure washer, except dry. It is accelerating steel shot at the floor through the machine, and that when it hits the concrete, it breaks away a piece of the concrete, and we're talking small piece of concrete because the steel shot is small, but those pieces that break away are equal to or a little bit larger than the size of the shot that hit it. When it breaks free under negative pressure, it's then extracted from the area back up into the machine, and then the dust goes to the dust collector and the shot gets recycled and reused again. So it is a captive blasting system. But the easiest way to explain it is, say, if anybody knows what a sandblaster is, it's completely dustless. The media does fly out of the machine, hits the surface, and then is recovered. A pressure washer, it basically does the same thing, but with water. It's dustless, but of course, just like sandblasting, the waste is not reclaimed. In a shot blaster, the dust and the shot itself, as they do their work, are reclaimed from the area so that the area stays clean as well as the area that's being prepared.
So going back to our CSP standard, based on what I've heard you say before, a shot blasting system or profiling is equivalent to a 3 on the CSP standard. Is that correct?
That's correct. It could certainly be made more aggressive based on the speed of the machine and the size of the shot. But to answer your question, yes, it would start at a CSP 3.
Well, that was kind of my next question, because I've seen shot blasters as small of 8-inch with a 110 volt power up to these monster ones that go in front of trucks. I would think that the bigger, more powerful ones are going to leave a deeper, more aggressive profile than the smaller ones. Is that based solely on the power and how hard that machine is hitting? Is it based on the size of the shot that's being thrown? Is it being a combination of everything?
The way that a shot blaster profiles a floor is going to be by two ways. The primary is going to be the shot that's thrown at the floor. The speed, the acceleration of the shot that flies from the blast wheel to the floor, that speed is fixed on, I think, all the machines. So there's no difference in the speed or the velocity of the shot. What changes based on the size of the machine, though, because of the input power, is the volume of shot. So if I can throw, to keep it simple, 10 pieces of shot at the floor versus 1,000 pieces of shot at the floor over the same time period, it's logical to expect that 1,000 pieces in the same time as 10 are going to do a lot more damage. They're going to break away a lot more surface of concrete. So one is going to be the volume of shot that I can throw at the floor, and that's going to be directly related to power. The other thing that is going to be controlled by the operator and, of course, the machine that is directly related to the profile creation is the speed at which it moves. When the machine is working and sitting in one spot, it will literally eventually blast a hole in the floor that will be a rectangle in shape. And the longer it sits there, the deeper the damage. And it's going to continue to blast into the concrete, sometimes all the way through to a couple inches. The traverse speed, or the speed of the machine as it crosses the surface, is going to influence the amount of damage that's done. And in a controlled way, damage the floor in a way that's uniform. Because whatever damage I do to the floor when I prepare it by grinding or shot blasting, it doesn't really matter. If I'm intending to coat that floor or treat it with a new floor covering of some kind, whatever damage I do, I have to fix it because I can't allow the damage I've done in prep to telegraph or reflect back through my coating or my flooring. So to answer your question, it doesn't matter the size of the blaster when it comes to the profile that can be created. The thing that matters is the operator and how that operator controls the volume of shot that's hitting the surface and how fast that machine is traversing the same surface. So there's a coordination there that has to be balanced if I want to have a repeatable and uniform profile on a floor that's 400 feet or 400,000 feet. It really is it's going to more depend on the way that the machine is run as opposed to its way of running.
So it sounds like it's controlled demolition, basically. It's combining several elements of the machine, the mechanics of the machine, the speed of the machine, to a controlled demolition of the surface that's going to give you a consistent profile. Is that fair to say?
It's fair to say, yeah. Like any mechanical process, it could be sanding wood. Same thing. If you leave a sander sit in one spot, it will just dig a low spot in the wood eventually, or the sandpaper will give out. Same with the shot blaster. I have to control the speed at which it's traversing or crossing over the surface so that my damage is done in a controlled way. And then, as I said, in a uniform way. Because when I put my coating or my floor covering on, if I have a floor that deviates by a couple mils or 20 mils because I've removed more concrete, less concrete, it's going to make it very difficult to stay in budget and bury that damage. So yes, it is controlled demolition from that standpoint.
So if I own one machine, so if I own a 110 volt 8-inch machine, which is very popular, within parameters, I can control the depth or the aggression of my profile based on the speed I am traversing across the surface, correct?
Correct.
Interesting. And that's true of all size machines. So even the bigger machines, the faster I go, the less profile, the slower I go, the more aggressive the profile.
Correct. I would say that when it comes to the bigger machines, it's going to be a matter of what is the size of the area that I'm intending to blast. That's going to, again, just like the grinder, is going to determine the appropriate model size. If I have 10,000 feet to do, then an 8-inch blaster, for how good it is and how precise it is and easy it is to use, I would never attempt that because it would take too long. Same as if I was to use, let's say, a big blaster, a 16-incher, a 480 volt machine, I wouldn't try to do a 400 square foot garage with it. And the reason being is because when I start to move up to those bigger machines, it's very difficult for me to move at a speed that is going to allow for, let's say, coordinated starting and stopping, where I can make it look as finely blasted as an 8-inch 110 volt, because it's like a racehorse. It's got a ton of power. And when it runs, the 16-inch window is going to have, compared to the 8-inch, it's probably going to have 3 to 4 times the amount, if not more, of the shot blast media that's flying through that circuit, hitting the same floor that, by comparison, the little 110 volt is barely touching it. So again, we're going to be back to, when it comes to surface preparation and the appropriate right machine, my question is always going to be, how many square feet needs to be done in a day?
Let's talk a little bit more about the engineering or the design of these machines. I've seen every size shot blaster that look, I don't want to say drastically different, but there's certainly measurable difference between the aesthetics of how these machines look. They look different. They're performing shot blasting differently. Can you go over a little bit about the differences, without naming brands, but talk a little bit about the differences of the machines and their engineering? And I would think at the end of the day, what we're looking for are machines that can give you a higher production rate, use less shot, and give you a more consistent result. So talk a little bit about your experience and your expertise on those, about the different designs.
When it comes to shot blasting and the relation between let's say the hopper area, we'll start at the point at which the shot begins the journey through the process of blasting the floor. The shot starts in the hopper, which is above the blast wheel housing. That is where the media is kept until it's used. So it's like a blast pod. So the steel shot is above the wheel. It drops into the wheel. That the wheel then takes that shot and accelerates it. And that is, unlike air, it's the motion of a manganese wheel that's spinning at over 6,000 RPMs that accelerates the shot and hits the floor. When it hits the floor, it breaks away a piece of concrete. And this happens a million times over because there's all these little pieces of shot that are doing exactly the same thing together. The shot bounces up along with the dust. So at an angle, as it hits the floor, it breaks it away, and then it rebounds. What we say rebound, or ricochet is another word that could be used, and bounces up under control and inside the housing into another section that's called a plenum, or rebound plenum. That basically means an area where the shot is expected to go when it rebounds off the floor. The shot blaster, no matter who makes it, is connected to dust collection. The dust collection, of course, is responsible for airflow. As that rebound creates a certain amount of inertia or velocity to that shot and bounces up, where it starts to lose velocity, the air movement from the dust collector picks up the rest of the path, meaning the air movement through the shot blaster grabs it before it slows down too much and pulls it up through the rest of the circuit and then back into the hopper. And of course, the dust is lighter, it leaves and goes to the dust collector. That is the circuit. It's a closed circuit. Because of that, that means any part of that process that is inefficient or prone for a slowing of the flow of the shot or the dust, then all the rest of the circuit is going to have to match or it will not be balanced. If it's not balanced, then that means the shot, when it's trying to do the work, it's going to fall on the floor and not be picked up because it's a moving negative pressure environment. The design is everything. The way that the circuit is designed, if there's any inefficiency, and it could be a small design such as the shape of the rebound plenum, if that shape hinders the amount of shot and dust that can clear the work area so that new shot can come in to create new waste and keep the circuit going, whatever the speed of the exit is going to determine the speed of the entrance. Because if the shot can't leave the area, then I can't put more shot in before it will disrupt the exit, in which case all the shot falls on the floor. So a machine's overall production is going to be determined by the slowest movement through that circuit, as opposed to any amount of power, any amount of metallurgy, any amount of engineering. Wherever its slowest point is in that route, that is going to be the maximum speed that's possible and still allow that circuit to flow. So, I mean, I know I touched on a lot there. It sounds a lot more complicated, but the reality is that the different designs, which I wouldn't say are secret, I don't believe any of them are patented. I think it's a matter of the time and the cost to create a machine that has maximum efficiencies built into the design of the machine. And that is exactly where a contractor could say this is justifiable because of this design. I may get 10 or 20 or sometimes 100% more production out of a machine, despite the fact that it's the same size and the same power input. But the magic or the secret, it's not really a secret. It's because the engineering allows for more shot to enter. And of course, that's because more shot moves out of the way.
So not all shot blasters are the same, is basically what you're saying.
No.
Let's talk a little bit about the dust collection that partners with a shot blaster. Obviously, you have to have a dust collection system that is compatible with the amount of dust that the shot blaster is creating. Talk a little bit about the importance of making sure, again, if I'm that contractor looking to make this purchase, that I am buying a sufficient dust collector to work with my blaster. And what happens if I don't? I would think that the blaster becomes a lot less efficient. There's more dust in the air. You know, I hate to see a contractor try to save a few dollars by spending for a premium shot blaster, but then not spending the money to get a premium dust collector.
Well, there's definitely a relationship between the amount of airflow that's required by the shot blaster to function at its maximum capacity and the possibility that it's going to be hindered also by too much airflow, because again, it's a closed circuit. That airflow is responsible for taking over at the point at which the inertia of the shot is starting to slow because of gravity. The shot blaster runs and moves. It won't run dusty is probably the best way to say it. It will not put dust in the air for very long, because unlike a grinder where it can leave dust on the floor, it can go in the air and it can keep working. A shot blaster requires that waste keep flowing. The shot blaster and its reliance upon that air movement is that it doesn't know to adjust how much dust it's making as, let's say, the vacuum filters start to get clogged up. That's why when it comes to dust collection and shot blasting, my advice to people is to take the recommendation of the dust collector. If they absolutely want to use a dust collector they already have, then to do some research on that particular vacuum, that dust collector, to make sure that it's going to provide the necessary air movement so that the shot blaster can function properly. Bare minimum 200, as an example, on a small blaster, bare minimum 200 CFM dust collector that does not have an automatic filter shaking system on it, I just had a question about this today. It will work, but I will have to stop the machine more often and manually shake the filters, because even though it's a 200 CFM, which is the bare minimum, those filters are not moving 200 cubic feet per minute, because as the dust comes to the filters and they're not cleaning themselves, my airflow is going to drop. When the airflow drops, I start to lose the ability to lift that shot and that dust and capture it from that closed circuit and get things separated the way they're supposed to. So that means that if that slows down, I'm going to start dropping shot more often. And if I'm lucky and I don't drop shot, at the very least, I'm going to have a dirty circuit, meaning the dust that is supposed to leave to the vacuum is now staying inside the circuit. And that, of course, is affecting how clean the shot is, and therefore how hard or how well it will hit. And also, because it's a dirty circuit, it's going to start to wear on the internal components much more quickly than if I was using the right size dust collector. The other side of it, though, if I happen to have a vacuum or a dust collector that's much more than I need, that's a good thing, except now it's going to be so powerful. The shot is clean, but it's sucking the shot out of the circuit before it's fully used. So now my consumption on shot goes up, and I have no appreciable improvement on production. All I've done is just drive my cost up of shot use, because the dust collector is sucking it out of the system before it's fully used. So it's a great question, and it's one that's worthy of discussion before a purchase is made or a decision is made, of why it is that a certain size dust collector should be used for a shot blaster.
Yeah, I mean, I think between the dust collection manufacturers and also the shot blast manufacturers, there are recommendations on certain CFM collectors to be used with certain blasters and certain applications, and certainly those questions should be asked. Along that point, I've seen enough of your videos where you talk about shot blasting as a dedusting process, and in those videos there is a measurable and noticeable visual difference between a floor that has not even it's been diamond ground, but between one that has been used, shot blaster to use just as a dust collection dedusting process versus not. Talk a little bit about the importance of why, even if you've ground it and you've got a dust collection with your grinder and you've even gone back with a wand and vacuumed the surface, why is it still important to go back and dedust with a shot blaster?
The fine dust that's created during grinding is, the majority of it's being collected by the vacuum. Whatever gets kicked inside the air, inside the space of the cutting area of the grinder, OSHA requires that the air be clean. So anything that would otherwise escape is being collected by the dust collector. The dust that's made during grinding, though, that doesn't get removed from the cutting area, is going to be caught underneath the diamonds and then redeposited into the pores of the concrete. Concrete is porous. This is exactly how coatings attach to concrete. The repetitive action of the diamonds over the floor, that's not only making dust and regrinding the dust that it's previously made, is turning it into basically baby powder. So it's very, very fine powder. At the same time, I have the repetitive action of these tools that are pushing it into the pores of the concrete. When I'm done grinding and I vacuum it, even if I vacuum it 3 times, and if people don't blast, the way to vacuum it is 3 times north, south, east, west, north, south. I mean, I'm going over it that many times because this is a future potential contaminant in, let's say, from the perspective of a coating. The way a shot blaster works, as we've talked about, the shot blaster shoots the media at the floor, and when it does, it's going to do some damage or disturb the surface of the concrete. Very similar to using like a household vacuum with a beater bar or a scrub brush. As that shot hits the floor, it hits it in a way that breaks maybe a little bit of concrete away, but that's really not the objective. It's more a matter of disturbing whatever baby powder fine dust is clinging to the surface of the sand or the aggregate, whatever it is on the concrete that's been previously ground and repacked with this dust. It's being disturbed by the shot, but it's being done under negative pressure. So that means as soon as that dust is disturbed by that shot, inside that closed circuit of negative pressure, it has nowhere to go but up. And that's why it's such an effective way to prepare a floor for any coating, simply because once the waste is made, it's completely extracted from that area. Now, I will say there are times where there's more stingy materials and products stuck inside minus imperfections on the floor that have nothing to do with mineral dust. But mineral dust is not really that sticky. It's just that a vacuum wand doesn't have a way to, it just can't be given enough time or the ability to go down and agitate that dust that's sticking to these surfaces and maintain a completely negative pressure. That's really why the visible difference that's observable after D-dust with a shot blaster, why it is so dramatic, because that fine dust is like a crystalline layer of powder over the whole floor that once it's removed, it's visibly noticed how much cleaner that floor is because it's taken all that white powder off of the entire surface.
Well, and I've heard enough coating manufacturers talk about their greatest failure, or the purpose of the reason for the greatest failure of coatings is dust and dirt left on the floor, because the coating is now adhering to a loose granular dust as opposed to the substrate. So the criticalness of getting that floor as dust-free as possible, to me, is worth the investment of a shot blaster just to guarantee you're getting that adhesion as strong as possible. Let's move on to the actual shot itself that you're putting in the shot blaster. There are a lot of different variations out there, sizes, configurations. Talk a little bit about that. Does that really fluctuate the results of what a blaster will do based on the shot that you put in it?
Yes. And this is something that I really don't have a lot of experience with when it comes to the different sizes and different mixes having different amounts of productivity or profiles, because concrete, again, being a changing natural material based on region of the country, what some people may use on the west coast of the US versus the east coast may be a different mix or a different size because the concrete's different. On the west coast, if it's normally hard concrete, and on the east coast, it's normally soft concrete. Just like with diamonds, what's appropriate in one place may not be appropriate in another. And that's from the standpoint of how much time does it take me to, in a controlled way, do destruction to the surface of the concrete. As you said, it's controlled demolition. So how I hit the concrete and what I want it to look like after hitting it is very much going to be influenced by the medium as far as the size of it. Shot, if you look at it from the standpoint of steel shot and size, if you consider 5 pounds of steel shot at a 280 size versus a 390, the higher the number, the bigger the shot piece. And it's noticeable. You can actually see the shot itself is larger in diameter. The 5 pounds of 390 shot will have less pieces of 390 shot than it will at 280. And the reason being is because per pound, the pieces are smaller. So that means the smaller size will have more pieces. The amount of inertia and the damage that is done as these individual tiny pieces of steel shot do, it stands to reason that the heavier the shot is, the 390, let's say, it's a bigger piece. There's something to be said for the chunk it's going to take out, because at the same speed as the small stuff, it's going to hit harder, right? Because there's a bigger amount of mass that's hitting into the surface and therefore a bigger piece breaking away. Well, a bigger piece breaking away a million times over is going to leave a floor more rough because the chunks that it makes are bigger. The bigger the chunks, the bigger the void that's left behind. Where with the small stuff, there are more pieces of it, but they are smaller. So that means the bites they take are not as aggressive and the floor is maybe less profiled. But it can go out the window if the concrete is harder or softer based on what mix used to be used for a different hardness of concrete. So it's not an exact science. I would say that there's probably not a lot of people that know a mix that would work every single place a blaster could go. But from a contractor standpoint, based on the region and what they're used to seeing, it's worth their while to figure out a mix that makes the most sense for what their objective is in terms of profile and what kind of concrete strength they're normally used to having to prepare.
This concludes episode 4 in a series of podcasts focusing on the basic principles of concrete surface preparation. Make sure to join us for episode 5, where we begin our general discussion regarding the popular, yet sometimes confusing topic of diamonds, and as they relate specifically to mechanical surface preparation processes. For immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit the Buy Manufacturers Direct YouTube channel. Simply visit the Buy Manufacturers Direct homepage and click Watch More Videos. New videos are added weekly, so don't forget to subscribe and click that bell icon to be notified when we post a new video.